The challenges of BIM implementation at national level. Good morning, my name is Sean McCormick. I'm your BRE host for today's webinar titled The Challenges of BIM Implementation at National Level. Before we get started, I thought I would give you a brief overview of myself. My official title is Senior BIM Advisor for BRE Building Research Establishment. My day job includes certification on both the BRE business and individual schemes relating to BIM Level 2 and ISO 19650, training where I'm involved in both the university and industry levels, and finally research where I've been involved in a number of EU initiatives relating to BIM. BIM is bringing about change in the global construction industry. To understand why, the following learning objectives will be covered within this webinar. Firstly, we will look at understanding the problems currently pervasive in the global construction industry and the drivers that have led to BIM adoption. We'll also look at understanding the importance of the standards that support BIM frameworks, specifically in the UK, aimed at negating these problems. We'll also obtain an overview of the international movement of BIM development, as well as an overview of the different strategies of BIM implementation and their challenges, and finally, understand some of the key principles of the new ISO 19650 standards. Dealing with the demands of change is the biggest challenge facing every organization today. In order to facilitate change, there must be drivers. The benefits of using BIM have been well established for decades. Although there have been recent improvements in technology, it is the pressure associated with the identified drivers which are pushing change. The current global drivers can generally be grouped under three headings, which are also the three pillars of sustainability. These are social, climate or environmental, and economic. Essentially, how we construct needs to change so that we can meet the needs of our emerging digital age, meet the needs of a growing global population, minimize the impact on the environment, maximize the use and value of resources, and provide economic viability and sustainability. Typically, these are factors that any disruptive innovation faces. First, we will look at the social impact as a global driver. To begin, let us put things into perspective. The global population is currently around 7.6 billion. By 2030, it will be estimated to be around 8.6 billion. And by 2050, the estimate will be around 9.8 billion. If the estimate for the year 2050 holds true, that means by 2050 there will be an extra 2.2 billion people on the planet. This equates to 7 United States worth of people, who will all need hospitals to be born in, homes to live in, schools to learn in, and offices to work in. Whilst this provides an incredible economic opportunity, in order to achieve such a goal, there is a need to ensure that we construct these assets as efficiently as possible. Now we look at the environment as a global driver. It is a fact that global temperatures are rising. Data collected by the National Oceanic and Atmospheric Administration, or NOAA, has shown that we have experienced 16 of the 17 hottest years on record since the year 2000. In addition, despite global initiatives, there has been a steady rise in global carbon dioxide emissions. As a result of these climate extremes, there has been an increase in both number of and cost of global events. The National Center for Environmental Information has produced data showing an increase in the number of global disaster events, which on average have costed over $1 billion each after being corrected for inflation over the last 30 years. Due to the increase of global disasters, there is a need to increase the resilience of our built assets, as well as allocate further financial resources to rebuild and repair existing assets. In order to do this, we need better information relating to our built assets and their performance. BIM therefore provides opportunity to aid with this. Lastly, we look at economics as a global driver. Due to the adversarial and competitive nature of the construction industry, profits are generally low. A review of the construction news revealed that the average profit margin of the top 25 grossing UK contractors was below 1.5%. To put this into perspective, this means that for every £100 worth of work they undertook, they were earning just £1.50. Up to the beginning of this year, unemployment rates were only just stabilizing back to the pre-2008 levels following the global financial crisis of 2008. Presently, we are witnessing the effects of a global pandemic on our world economy, the effects of which have not yet fully been calculated and understood. A recent ONS, or Office for National Statistics, monthly figures showed that the economy plummeted by 20.4% in April this year, the largest drop in a single month since records began. The fact is construction creates jobs, but due to the nature of the construction industry, it is the first hit and the last to recover in an economic crisis, as other sectors won't engage with construction unless they are stable themselves. Again, BIM is seen as an opportunity to increase the economic performance of the construction industry by reducing costs and risks whilst improving performance and productivity. However, the construction industry needs to invest to facilitate this. Reducing inefficiencies will have a radical impact on economic drivers. For example, UK construction outputs contribute around 7% to the UK's GDP, which equates to around £110 billion. However, following research by both the Construction Industry Institute and the Building Smart Alliance, potentially over half of all project costs can be attributed to non-value adding effort or waste in resource and materials. The UK exists within a global market. As such, the UK, as well as other nations' construction industry, cannot afford such inefficiencies if it aims to compete at a global scale. Through BIM Level 2 and other means, the UK government is taking its first step towards reducing this inefficiency. Since 2016, the UK government has targeted a 20% reduction in capital costs of assets and targeted a 33% reduction in overall whole life cycle costs by the year 2025. The benefits of using BIM for design and construction are generally well understood and documented. The production of clear, correct, and unambiguous information is central to BIM adoption, but so is meeting the global social, environmental, and economic drivers previously highlighted. The intention for extending building information modeling to BIM as information management will facilitate informed decisions. The 2011 UK mandate announcement for BIM Level 2 recognized that for design and construction, the advantages of those informed decisions could add a 20% reduction in capital expenditure, which is a massive driver for BIM adoption. The perception for those that work primarily in design and construction is that BIM is a solution for better information used to resolve their decision-making problems, and as such provides a massive opportunity. Actually, the massive design and construction opportunity is tiny when taking into account the enormous opportunity that exists over an asset's life cycle and the real benefits this could bring. Whilst design and construction is insignificant when compared with the size of operation and maintenance, the business costs and business outcomes are significantly larger and are where the ultimate value is for informed decisions based on accurate information. One of the main concepts behind the UK BIM Level 2 approach was beginning with the end in mind. When this meant asking designers and constructors to provide the information in the appropriate formats to support not only the operation and maintenance requirements, but also the business costs and outcomes requirements of a business. If these requirements are not provided, it is unlikely that the information will be provided to meet those long-term aims and actually support the decision-making process. At this particular point, I would like to briefly talk about the effects of poor information, which standards, methods and procedures defined within the British Standards BS 1192 are meant to address. Shown here is an overlay of two drawings, the blue drawn by the architect and the red drawn by the engineer. As you can see, there are several discrepancies between both drawings, such as the location of the stairs and the ductwork. Because of this uncoordinated information, several assumptions would have been made, such as, who do you trust? As they have both drawn the stairs, which one is in the correct position? If the engineer is correct, then the D046 won't get built as it doesn't appear on the engineer's drawings. If the architect is correct, then the engineer will need to move their downpipes as they clash with the insulation. Either decision will have an impact on site, resulting in additional costs. It is uncoordinated information, such as the example shown, that makes design difficult to build. The perception is that uncoordinated information is a result of working within a 2D environment. The reality is that just because elements are modeled in a 3D environment does not mean that errors will not occur. As well as undertaking 3D modeling, an information management process is required to ensure that coordination issues are resolved as part of the process and not left to resolve on site. The following is a list of what may cause the output of poor information on projects. Lack of coordination between designs. Without a defined origin point, it will have been difficult to compare and align designs from different task teams. Lack of clear lines of responsibility. Without a firm responsibility matrix, elements will be produced on drawings multiple times, increasing the likelihood of errors. Lack of clear information requirements. Without a clear idea of what information is needed to be produced, information will likely be incomplete or ambiguous. And lack of communication between design teams. Without a clear communication between teams, designs are produced in isolation, meaning that information needed by other task teams is missing, and clashes will often appear without any communication. So what are the effects of poor information? Well, abortive work, for one. For example, there is no need for both task teams to draw the stairs. The time taken to duplicate the work of another's team does not add value to the project and increases the risk of errors being produced. You will experience problems on site. If drawings don't align, what happens if you trust one set of drawings and it has an impact on other elements being constructed? Uncoordinated information like this is bound to cause an impact issue. Poor building performance. With longer runs of pipe work and awkward junctions, the original design has been compromised and the performance will suffer as a result. And lastly, frustration, because while you may not have produced information, your decisions will be based off of the information, meaning that you have a vested interest in making sure it is correct when it arrives on your desk. Studies from the USA, Scandinavia, and UK suggest that up to 30% of construction is rework, meaning that almost a third of all project costs and resources are associated with amending work already completed. Labor is only utilized 40 to 60% efficiency, either through waiting for material to arrive on site, instances where work is incorrectly programmed out of sequence, or even weather issues can hinder the efficiency of the labor force. At least 10% of site material is considered waste, either through offcuts and under a standardized design such as brick dimensions are not being used for masonry walls, or through the removal of material due to rework. Much of the material brought to site is not used in the final asset. And accidents account for 3 to 6% of project costs. Through the disruption of work, damage to plant material, or expensive health and safety investigations, accidents can account for a significant value of the project. Put together, this adds up to an average of 50% of the cost of a project being put against non-value adding work, meaning that poor information results in projects that are difficult to build and design and are being built by an underutilized labor force who have a higher risk of injury, resulting in wasted resources and materials, the project costing double what they should. Next, I'd like to look at the steps industry has taken to improve performance and cut down on the inefficiencies identified. Progress, far from consistent in change, depends on retentiveness. When change is absolute, there remains no being to improve and no direction is set for possible improvement, and when experience is not retained, as among savages, infancy is perpetual. Those who cannot remember the past are condemned to repeat it. These words, written by George Santayana in 1905, are key to the progressive development of any industry. No matter how far we develop, those who cannot remember the past are condemned to repeat it, just as UK construction industry, for example, cannot remember its past. The cost impact of poor information and poor coordination has been published for decades. In 1976, BRE published Coordinating Working Drawings. This publication surveyed the effects of poorly coordinated working drawings from 25 different construction projects. The report collated the results and displayed what were considered to be the key factors which caused poor coordination on these projects. In 1987, in an attempt to aid the industry, the Construction Project Information Committee, CPIC, formerly known as BPIC, Building Project Information Committee, was formed under joint sponsorship from a number of industry bodies. Through this committee, several documents were produced to aid the construction industry to overcome some of the inadequacies found in practice which were seriously impacting on the efficiency and quality of building work. Unfortunately, these documents were not adopted by industry at the time. Following a poor uptake, in 1993, a case study demonstrating how CPIC documents could be applied to a project was published. While the case study did not help the industry adopt these documents, it demonstrated the need to introduce industry standards. Following the poor uptake, in 1994, the Latham report titled Constructing the Team was published. Constructing the Team was one of many publications which were critical of the UK construction industry, using several negative terms such as ineffective and adversarial. Constructing the Team identified better project team integration as a means to achieve better value for money. Based on the recommendations within, the Latham report suggested that a 30% reduction in project costs could be achieved. 4 years later, the Egan report titled Rethinking Construction was published. This report was commissioned to look at the progress UK construction industry had made since constructing the team. The results were not positive. There was a deep concern that the industry was underachieving. It suggested that the industry had low profitability and did not invest in research, development and training. Rethinking Construction, much like Constructing the Team, also recommended further client involvement and better project team integration, noting that projects with client-led initiatives had seen dramatic improvements. Concluding the report, new targets were set, including an annual capital cost reduction of 10% as well as a reduction in post-construction defects by 20%. Following the poor uptake of the CPIC documents published back in 1987, they were revised and combined into a single document, updated to suit CAD processes. This combined document was then released in 2003, titled Production Information, a practical guidance on the preparation of good production information, making optimum use of widely adopted computer systems. Production information was published under the tagline that information is invariably inaccurate, ambiguous, and incomplete. Unfortunately, the good practice information included was not adopted by industry, demonstrating once again that we had failed to learn lessons from the past. What can be seen is that by not learning from the past, there has been a perpetual criticism of the construction industry for decades about its inability to construct effectively. Two key themes consistently perpetuate. The first is that the construction industry needs to become less antagonistic and more integrated. By working together as opposed to working against each other, efficiencies can be identified and improvements gained that benefit the whole team. The second is that client involvement is key. Without an engaged client, the ability for the project team to satisfy their requirements and business needs will be diminished. The more active a client is in the beginning with the end in mind, by providing an output-based brief, the more likely the project will be a success. Clients, too, must accept their responsibility for effective design. The UK government were well aware of the level of poor information in construction. Reports they had commissioned, such as Constructing the Team and Rethinking Construction, have been identifying the level of waste within construction for decades. Tired of commissioning reports, Sir John Egan, as chair of BAA, wanted to ensure that the effective delivery of Heathrow Terminal 5 would be undertaken. To do so, Sir Egan specified the use of standards, methods and procedures outlined within production information and engaged with Constructing Excellence and Avanti to ensure that the supply chains were sufficiently competent to comply with these standards, methods and procedures. After successfully saving 10% of the initial project cost, Sir John Egan commissioned the Department of Trade and Industry (DTI) to replicate this process, as well as measure and validate these savings on other projects. DTI then commissioned Avanti to undertake this consultancy and a third party to undertake the measurement. The following are key objectives outlined in what is termed as the Avanti approach. The approach looks at increasing the quality of information, increasing the predictability of outcomes, and reducing risk and waste on projects. This was done through the extensive consultation with clients, end users, and project delivery teams. Over the course of the Avanti program, the following savings were identified through the use of the Avanti approach. There was a 50 to 85% savings on effort spent receiving information and formatting for reuse, a 60 to 80% saving on effort spent finding information and documents, a 75 to 80% saving in efforts to achieve design coordination, a 50% saving on time spent to assess tenders and award subcontracts, and a 50% saving on efforts in subcontract design approval. These savings came from applying the information management processes developed initially by CPIC and then published in production information. Based on the success of the Avanti program, work began on developing standards, methods and procedures which were then used to develop British Standard BS 1192. This standard would become a code of practice, meaning that this way of working is seen as the best practice and should be adopted without revision. BS 1192 covers what we know as the common data environment, file naming conventions, the use of status codes, and revision codes. Unfortunately, even with the publication of the British standards, these coordinated standard methods and procedures were not widely adopted by industry until BIM Level 2 mandate was introduced in the UK. The BS 1192, along with PAS 1192 suite, which were developed between 2007 and 2018, would form the core documentation defining BIM Level 2 requirements within the UK. Knowing that it would not be possible for the industry to fully adopt information management processes immediately, a maturity model was developed by Mark Bew and Mervyn Richards and then used to form a roadmap for BIM adoption within the UK construction industry. The maturity model was drawn as a ramp to demonstrate that this is a journey of improvement, with the first hard target being set at having all centrally procured government projects follow BIM Level 2, requiring information management from April 2016. As you can see, the ramp extends beyond this target, demonstrating that BIM is not a quick fix, but a long-term strategy to improve the UK construction industry for the better. Following international interest, some of the UK BIM Level 2 related standards are being incorporated into international standards ISO 19650 Part 1 and ISO 19650 Part 2. These two international standards have incorporated BS 1192 and PAS 1192 Part 2. This activity in the International Standards Organization shows that the UK BIM Level 2 process is seen internationally as good practice, providing the UK standards with relevance within Europe and across the globe. Next, I would like us to have a closer look at the adoption of BIM across the globe. What we find is that BIM is being adopted globally, but with varying levels of implementation. Everybody is recognizing that the construction industry needs to change. Some countries like the UK, Sweden, and Dubai have types of government mandates in place for a top-down implementation. Other countries, such as Australia, have a lesser mandate. Within countries like the US, Russia, Chile, Peru, and Singapore, BIM is obligatory for central government projects or projects over a certain size, and many others have a more informal program or plan in place for BIM adoption. The Africa continent is considered to fall into the category of new adopter countries. An article from the MDPI Construction Journal in 2019 revealed a varying level of BIM growth, with North Africa, West Africa, and Southern Africa leading the research development of BIM implementation, whilst East Africa and Central Africa are slightly lagging. The following is an extract from a 2019 UNESCO report. With an estimated population of 1.216 billion as at 2016, and which is expected to double by 2050, the African AEC industry is expected to grow at a fast rate in the next 5 years and will become a major player in the global construction. Research shows that there is a high number of BIM publications from Egypt, Nigeria, and South Africa, indicating a high level of awareness in these countries. Despite this, the level of awareness amongst African countries collectively is below 50%. It is worth noting, however, that level of awareness does not necessarily imply level of implementation. Awareness is a stage in BIM innovation diffusion, and it differs from BIM implementation. A further review of the MDPI Construction Journal found that BIM adoption within African countries is driven by a bottom-up approach through local enterprise keen to innovate and adopt the benefits that BIM provides. These private initiatives are being undertaken without the support of government. Here are some key barriers of BIM adoption within Africa. So there's a lack of skilled personnel owing to lack of awareness and training. There's a lack of government support, as already alluded to. There's a lack of investment by private industry and government. There's a lack of BIM standards at national level, resulting in organizations adopting a patchwork of different standards where adopted. And there's also inadequate infrastructure within many African countries to enable BIM adoption. South America also falls into the category of new adopter countries. Countries leading the way of BIM adoption across the continent are Brazil and Chile. The Chilean government have their own implementation strategy, Plan BIM, a 10-year initiative with its main goal to use BIM to manage public building and infrastructure projects by 2020 and the requirements of BIM for private projects by 2025. The BIM Forum Chile is the main technical reference and meeting point in Chile around BIM, generating projects, activities and standards that add value to businesses and professions within the AEC sector. In May 2018, the Brazilian Ministry of Industry, Foreign Trade and Services, MDIC, launched a national dissemination strategy for BIM with the purpose of promoting investment in BIM and its diffusion in the country, raising the participation of civil construction by 28.9%. One of the key drivers pushing the adoption of BIM at national level is Brazil's housing demand. A survey conducted by the Sao Paulo State Housing Syndicate estimates that between 2015 and 2025, Brazil must build 14.5 million new homes to meet the housing deficit. The national strategy is divided in 3 phases. The first phase, starting January 2021, focuses on architecture and engineering projects for new construction extensions or rehabilitations. The second phase, starting January 2024, which involves planning of the execution of the work for new constructions, renovations, extensions, or rehabilitations. And the third phase begins January 2028, which covers the entire life cycle of the work when considering post-work activities. As well as the national initiatives, the BIM LATAM has been set up, which involves several Latin American countries collaborating together within Latin America and as well as globally. The adoption strategy within these countries is considered to be top-down approach, owing to mainly government initiatives driving BIM implementation. From an EU perspective, several countries have initiated national BIM programs to promote BIM capability, which indicates a top-down approach. The EU Commission recently awarded the EU BIM Task Group funding to deliver a common European network aimed at aligning the use of building information modeling in public works. As a result of this, the EU BIM Task Group produced a handbook looking at the developing policy to support the introduction of BIM, as well as two frameworks designed to develop standards and drive the implementation of BIM respectively. These include a common performance definition of BIM and a strategic framework for public sector-led BIM programs. In summary, the following strategic implementations have been taken place within the EU. The French government deploy a BIM strategy within the housing sector on delivering 500,000 houses in 2017. The Le Plan Transition Numérique dans le Bâtiment, a task group, is responsible for the French roadmap. In Germany, after a number of high-profile jobs ran significantly over budget, the Planenbauen 4.0 Limited company was established. Planenbauen 4.0 Limited was responsible for leading and steering the implementation of BIM at national level towards the German government's 2020 mandate. Italy introduced a BIM mandate in October 2016 for all public works above €5 million. Spain introduced various BIM mandates in 2018 and 2019. To assist with the implementation of BIM at national level, a steering commission for implementation of BIM methodology was set up. Lastly, the Scandinavian countries have been leading BIM for several years. In Finland, the Confederation of Finnish Construction Industries decided in 2002 that BIM would be a core element of their proposed changes in the AEC sector. In June 2011, the Danish Parliament extended the mandatory adoption of BIM to all local projects worth €2.7 million and central government projects worth €677,000. And the Norwegian government established a national mandate in July 2016. Then there is the Asia Pacific BIM Group, supported by the Hong Kong Construction Industry Council, which has issued a roadmap for BIM strategic implementation in 2014. In China, the Ministry of Rural Housing and Rural Urban Development have specified a 5-year BIM plan. A recent McGraw-Hill Smart Market report on the value of BIM in China reported that the percentage of those using BIM on at least 30% of their projects was expected to grow in the next 2 years by 90% among architects and 110% among contractors. The Chinese BIM Union have also been instrumental in developing the Chinese National Unified Standards. A great deal of development in Asian countries is also being funded by China across countries such as Hong Kong, Cambodia, Thailand, Malaysia, and Singapore. The strategy for BIM implementation in China is very much a top-down approach by government. The US falls into the category of countries with an advanced framework for managing construction using BIM. Digitization within the US AEC industry began in the early 1990s with the establishment of the International Alliance for Interoperability, or IAI, which later changed its name to Building Smart. while a national BIM policy and mandate were introduced in 2003 and 2007 respectively. The American Institute of Architects were actively utilizing the BIM concept that facilitated the central government involvement in the early stages of BIM adoption. The government subsequently legislated BIM in 2007. The BIM diffusion mechanism in the US market is currently middle out, running concurrently with bottom up, although in the past a top-down approach appeared to be a strategy due to the government agency and large client involvement. Utilization of BIM in the US lacks a unified national standard for project delivery. Absence of this standard is providing open deliverables that become dependent on a client-to-client or even project-to-project basis. Various government departments in the US are producing their own standards and publishing them in places like National Institute of Building Sciences, or NIBS, which is then used on projects without alignment with other state standards. Australia also falls into the category of countries with an advanced framework for managing construction using BIM, along with the US and the UK. BIM is being moved by both the government and industry stakeholders. The move is in collaboration between government and non-profit organizations through the development of National Specifications, or NatSpec, in 2011 and the subsequent release of their first BIM framework in 2014 by ACIF-APPC. Although there is no national mandate in general, there is a restricted one for New South Wales Health on projects exceeding $30 million. The diffusion dynamic in Australian market is currently considered bottom-up. This brings us to the end of the overview of global BIM implementation. You will note that I did not focus on the UK within this section. This is because the narrative of this presentation covers this topic. For BIM to be successfully adopted at international level, then a uniting standard is essential. The new ISO 19650 suite of documents provides us with this opportunity. Over the course of the next set of slides, I will be providing an overview of information management as outlined in ISO 19650 Parts 1 and 2. ISO 19650 is a standard for organization and digitization of information about buildings and civil engineering works, including building information modeling, or BIM. Part 1 covers principles and concepts. Part 2 covers the delivery phase of an asset. By reviewing these documents at high level, we will ensure that the key considerations of effective information management and associated processes have been sufficiently understood. This is important when considering the implementation of BIM at project, organizational, or national level. Firstly, let's look at what we mean by ISO. ISO is not an abbreviation. It is derived from the Greek isos, meaning equal. Whatever the country, whatever the language, ISO is always used as the abbreviated form. ISO is an international organization which was formed with a vision to facilitate the international coordination and unification of industrial standards. It was formed back in 1946 to achieve this vision. Today it has over 165 countries as members. In order to improve outcomes for everybody, the World Economic Forum has said that we need global conventions to improve performance. To achieve this, an international standard for BIM, ISO 19650, was developed. In order to accelerate the adoption of the standard, they recommend each country look at the following steps. Articulate BIM's benefits across the entire life cycle. Consider BIM as a value creator, not a cost factor. Approach BIM as the essential first step to digitization. Use integrated construction and redefine risk-return mechanisms. Set up early collaboration and communication among stakeholders. Establish data sharing standards and open systems. Support the development of BIM skills along with full value chain. Change behaviors and processes, not just technology. And finally, make long-term commitment and support innovative financing. Please note there is the flexibility within ISO 19650 for each country to write their own annex to the standard. This diagram shows the requirements for organizational management and reflects the diagram shown in ISO 19650 Part 1, depicting how information is managed through the entire life cycle of an asset. As can be seen, organizational management is supported by asset and project management, which in turn are supported by information management. It shows the split of an asset's life cycle in the delivery phase where A is the start of the delivery phase where existing asset information comes into the project, B is the progressive development of information, namely the PIM or project information model, and C is the end of the delivery phase. It also shows the operational phase with the circle indicating changes, including modification and refurbishments to the asset. They may occur during its operation. This whole process is supported by other relevant standards including data quality, information security, and risk management. This is the new maturity wedge as opposed to the BIM Level 2 maturity wedge defined within PAS 1192 Part 2. The ISO now talks about stages relating to BIM maturity rather than levels, and there are layers for the elements. There are 3 maturity stages showing increasing benefits from collaboration and processes depicted. There are 4 layers depicted across all stages, including standard layer, a technology layer, an information layer, and a business layer or level. The ISO 19650 definition of BIM is defined as the use of digital representation of a built object to facilitate design, construction, and operation processes to form a reliable basis for decisions. Building information modeling is used to produce coordinated design information and documentation, predict performance, appearance, and cost, and deliver projects faster, more economically, and with reduced environmental impact. To achieve these benefits, coordinated and reliable information is required to act as a single source of truth. This mitigates duplication, reducing ambiguity, and therefore improving the quality of information. The ISO standards are very specific in both their terms and their requirements. For example, if a clause includes shall, then the clause must be followed. On the other hand, if it includes should, then following the clause is a recommendation. Similarly, if the clause includes shall consider, the clause should be followed as best practice unless there is a good reason not to. One of the things ISO 19650 does talk about is the suitability of the use of standards dependent on the size and complexity of the project. For example, on a very small project, the use of all their requirements may be excessive. These are the areas where should and shall consider are used. Another principle to understand within the ISO is the term function. A function is a set of tasks or activities to achieve an objective. Functions should be allocated to one or more individual, either embedded within the appointment through a schedule of services or by more general obligations. There are 3 types of functions, and it is essential that these functions are formalized in some way. There is the asset information management function, which includes tasks in relation to the operation of an asset. The project information management functions, which includes tasks in relation to the delivery of an asset, and task information management functions, which includes tasks in relation to the production of information. To support organizations that have not yet adopted information standards, ISO 19650 has simplified the information management process. The responsibility for information management is distributed across the whole team, with individual parties being given specific tasks. However, each party has flexibility in completing these tasks. For example, they could delegate it in their team or even employ a third party to complete it. This is the difference between the way PAS 1192 allocated tasks. PAS 1192 Part 2 defines functions like task team managers, task information managers, whereas the ISO does not. The ISO merely notes that these responsibilities need to be met. Tasks related to these functions defined in the ISO are then allocated to parties by way of a Raki matrix. Another change in terminology from PAS 1192 Part 2 are what members of the project are called. The terms appointing party, the lead appointed party, and appointed parties are now used in place of PAS 1192 Part 2 terms such as client and lead supplier. Here we have a contractual tree which better explains the relationship between the different parties on a project. The appointing party appoints a delivery team which is led by a lead appointed party. The lead appointed party will then have a number of task teams producing deliverables. The need is communicated down through the appointments, including the EIRs. Then the required deliverables are communicated back up the tree. Further terminologies include appointments, which replaces the term contracts. These are agreed instructions for the provision of information concerning works, goods, or services. And then, of course, we have appointing party, which we've already discussed, which replaces the term client. And the formal definition of an appointing party, is this is the receiver of information concerning works, goods, or services from a lead appointed party. And then we have the terms lead appointed party and task teams. These are providers of information concerning works, goods, or services. Another concept to understand is the information management process. An information management process is started each time a new appointment, formal or informal, is made, and involves the following activities, including the preparation of information requirements, the review of prospective task teams, including sub-appointments, the planning for how and when information will be delivered in relation to information management capabilities, and the review of information deliverables against information requirements against the acceptance criteria established for each information requirement. The information management process should be applied proportionately, and that is in a way that it is proportionate to the scale and complexity of this task. Here we will look at the information management process in a little bit more detail. So what there is in the activity sequence is a series of activities which define an information management process. The information management process is started. Then per project there is an assessment and need and project closeout. Then per project there is an information procurement, which consists of the tasks within the invitation to tender and tender response activities. Then we have information planning, which consists of tasks within appointment and mobilization activities. And then we have information production, which consists of tasks which within collaborative production of information and information model delivery. These are the key areas the ISO is dealing with, and although they are very similar to PAS 1192, they are worded slightly differently. However, the ISO is more definitive in what processes need to be carried out and is more detailed on what needs to happen in each of those activities. The ISO 19650 also talks about the need for clearly defined information requirements, which goes back to the Egan and Latham reports we touched on earlier, highlighting all the issues with the clients not defining what is needed. Here we see the process relating to providing clear defined information requirements. So firstly, the appointing party needs to state what is needed on a project. Then the lead appointed party provides a plan for how and when to deliver the information on the project. Then the delivery team deliver it. Then the appointing party approves the information, or the non-approvals are fed back. The requirements or delivery can be changed as necessary. The ISO talks about the technology supporting the information modeling standards, and that the technology solutions need to be able to provide the following requirements. Firstly, a common data environment. So does the intended technology solution utilize the specified attributes of status, revision, and classification? Next, we have the approval process. So does the intended technology support testing information against the project's information standards? Then we have the authorization process. So does the intended technology solution support testing information against the exchange information requirements? And lastly, an acceptance process. Does the intended technology solution support testing information against the appointing party's acceptance criteria? When considering supporting technologies for BIM projects, they must align with the process of the common data environment as defined within ISO 19650 Part 1. At the core of the BIM process is the common data environment, which is a process, not a software solution. There are four main stages or states within the process. As we can see in this diagram, we have the work in progress, the shared, published, and archived. This process ensures information is exchanged through a shared location where files are held for everyone to access. This means that there is a single copy of each file which needs to be updated and a single location to find it. In other words, a single source of truth. A major concern with BIM is sharing the correct information with stakeholders whilst at the same time protecting sensitive information for unauthorized access. ISO 27001 is the main IT security standard which has helped to define ISO 19650 Part 5, the ISO relating to sensitive assets. Many companies are moving towards ISO 27001. The ISO also talks about asset information security and how the following types of security risks are dealt with, including hostile reconnaissance, malicious acts, and disclosure of sensitive information. The term sensitive information includes intellectual property, commercially sensitive information, and personally identifiable information. There may be sensitive information that the employer does not want out in the public domain for security issues. For example, the CCTV system, such as where the cameras are placed. Most of the other information on a project would be available to all stakeholders, but this information would not be. Within the UK, there are other schemes which are being driven by government to assist organisations meet a certain IT security standards, such as Cyber Essentials and Cyber Essentials Plus. So, by following and implementing the concepts and principles discussed in previous slides to collaboratively produce a federated information model, an organisation can be said to be doing BIM according to the ISO 19650 series. This brings us to the end of this presentation. You should now be able to understand the problems currently pervasive in the global construction industry and drivers that have led to BIM adoption, understand the importance of standards that support BIM frameworks, specifically in the UK, aimed at negating these problems, obtain an overview of the international movement of BIM development, obtain an overview of the different strategies of BIM implementation and their challenges, and finally understand some of the key principles of the new BIM 19650 standards. Thank you.